Hi and welcome to Classic ATS. During this 8-part series we're going to show you how to fully build your 911 air-cooled cylinder head.
To clean the valves, it's a two-step process for me. Firstly, what I'll do is, especially on the exhaust, there's a lot of carbon buildup on the back of the valve as well as on the front. So usually what I'll do is take this to the wire brush first and then clean it up finally with a light bead blast. So make sure you're wearing your safety glasses when you are using a wire wheel. I'm just going to run it up. Usually I'll take the head off first and I'll just kind of rotate it and you'll see it'll clean it off fairly quickly. Next I'll run the margin. And lastly I'll get in on the back of the valve. Usually what I'll do is I'll hold the valve in up against the seat and I'll let the wheel rotate against it. And then just pick up any last pieces of carbon. And we can see there's an exhaust valve. Then we're going to do the same with an intake valve. Same thing, intake valves typically have a dish. Can be a little bit hard to get into. So I'm just going to take the outer, push it in, rotate. We'll get the last of that with the bead blaster. Same thing, we'll get the margin, and then get the back of the valve. Still got a couple of little pieces of carbon. We'll get that off in the bead blaster. So now that we've got all of our valves and all of our springs and retainers cleaned up, we're going to start the inspection process. I'm going to start with the valves, and I've got my specifications for this engine. This is a 1969 2-liter engine, so I'm looking at the valve specifications for that. But before we start measuring, we're going to start by using our flashlight and just going over the valve and looking for any obvious signs of defects. Now, what we're looking for is any kind of pitting or rusting around the valve head. And what this will do is, especially with sodium valves, more so on the exhaust side, it can cause the valve head to break off. So that's an automatic discard. This valve we can see has quite a bit of wear on the valve face, but that'll be corrected on the valve grind, so I'm not too worried about that. The next part I want to look at and pay attention to is going to be the stem, which is going to be right here. I'm looking for any obvious signs of galling or scratching, heavy scratching that would influence how it's going to operate in the guide. Then I'm going to be looking at the collet area. This is where our collets will lock into. So these grooves have to be clean and tight. So this is a collet. You can test fit a collet. Make sure it fits on nicely and doesn't have any excessive amounts of play. So after the visual inspection, the next point is to measure the actual stems. So we're going to be measuring the valve stem at 3 places. We're going to measure it at the bottom, the middle, and the top of its usable range. The tolerance on these, or the factory dimension on a new valve stem, on the intake valve is 8.970 to 8.958 millimeters. And it has a wear limit of 0.01 of a millimeter. So what that means is any dimension that is at 8.948 or below is going to show the valve stem as undersize. So I've already got my micrometer zeroed, and I'm using a micrometer stand to make it easier. And what I'm going to do is I'm going to start measuring at the top of the usable range. Usually if I come up to the very top, just above or just below the collet area, you'll see what the valve was brand new, so it's new dimension as this area doesn't wear. we have 8.96. And then I'm going to move it down into the wearing range. First dimension I have is 8.953. Then in the middle of the guide I have 8.96. And at the bottom of the usable range we have 8.916. So that means that we have a taper on this valve where it is worn from the top to the bottom of approximately 0.05 of a millimeter. So this valve is not usable. So I'm going to continue to measure all of the intake valves, and any of the intake valves that are out of tolerance, I'm just going to move them over to one side. Any that stay in tolerance, I'll put them back in my lineup to be further processed. Next, I'm going to do the same with the exhaust valves. So the exhaust valves run a larger tolerance or a larger clearance between the guide and the valve, so consequently the stem size starts off being a little bit smaller. The specifications for a new valve is 8.950 millimeters to 8.938 millimeters with a wear limit of 0.01. So that means anything that measures 8.928 or below is going to be a discard. Same thing, I'm going to start measuring at the top of the valve, and I want to measure it in 3 places again. So we have 8.94 at the top, 8.94 in the middle of the guide area, 8.940 at the bottom. So this valve stem is usable, and so we'll put it here and we'll continue on and measure the rest of the valves. So now that I've visually inspected and measured the stems on our valves, I have the valves that have passed that inspection stage so far, and the next part is to remachine the face of the valve. This is where it contacts the seat, and we're also going to address the back of the valve. This is where it contacts the rocker. So I've got my valve grinder or valve refacer set up. I have my chuck here set up on a 45-degree angle, but before I can start refacing the valves, I'm going to use my diamond right here, and I'm going to dress the cutting stone just to make sure that it is nice and flat. Every time that you machine a valve, the stone will wear slightly, so in between jobs it's always a good habit to lightly reface the stone, and that's going to vary from machine to machine. Next, I'm going to start with my intake valves. So to do this, I'm just going to slide my intake valve into the collet. And I want to set it up so I can repeat with all of the valves, and I want to be retaining perfectly on the stem. So this particular machine has a stop that I can push in that will engage the back of the valve. That way I know whenever I install the next intake valve, it'll be in the same spot. Then I'm just going to tighten the valve up onto the collets and make sure that it can run through its operational range. Next thing I want to do before I start cutting is I'm going to turn on my coolant. And this is, we want to keep this running over the valve at all time. This keeps washing away any of the debris from the stone and from the metal. It also keeps the valve cool. When I bring it in, I also want to make sure, just by visually looking at the valve, that it is running true. If it's bent, you will see the valve physically moving, in which case there's no point continuing with that. As I bring it in, I want to keep the valve carrier moving. I don't want to stay in one spot, and I just want to make small changes. Once it starts to cut, I'm looking for the finish right here and making sure that I'm getting an even pattern all the way around the valve. And you can see I'm moving the valve back and forth across the stone. When I'm done, I want to back the valve out. I don't want to just drag it off the edge of the stone. If I drag it off the edge of the stone, it will cause the valve to flex slightly and we won't have a truly concentric grind on the valve. The last thing I'm going to do is I'm going to just pull it out of the collet, and I want to rotate it and inspect it to make sure I don't have any areas that have not been reground. So now I can go ahead and put in my next intake valve till it hits the stop, tighten it back up. I always like to back it off a little bit so I know that I'm not going to run into the stone. Now this valve had a lot of wear, and I just wanted to show you how we've started grinding, but we still have a big valley down inside the valve there where the stone hasn't started to cut yet. So this valve is going to take a lot more to clean that up. Looks like it's cleaned it all up. When I put in my exhaust valve next, I've cut my two intake valves that measured up correctly. My exhaust valve, I can use the same stop point, but I'm going to have to reset my distance away from the stone, only because the head of the valve on the exhaust side is considerably smaller than the intake. Another thing that you want to always keep into mind when you set up your valve in the collet here, you want to make sure when you come in that you don't ever come in so far that the stone can run into the stem. If you do damage the stem, particularly on the exhaust valves, then you need to go ahead and discard that. So I'm just going to move this closer before I turn everything on, and we're going to go ahead and cut the exhaust side as well. So to dress the back of the valve, which is going to be right here, this is where the lash cap runs and presses down. And though usually these don't tend to suffer a lot of wear, sometimes you can get some wear, so I'm going to show you how to dress that. What we're going to do is we're going to lay the valve on top of this little V-block here. I'm just going to put that adjuster in, and I've already zeroed my scale. Down here on my wheel I have a small scale. It's in thousands, so you'll have to do your conversions to metric. But what I want to do is I'm just going to slide the valve out until it just contacts the stone, and then I'm going to bring the lock over and just carefully lock this valve in place. Then I'm going to take my guide right here, I'm going to pull it out until it contacts. This will make it repeatable for the rest of the valve, so I can take the same amount off on each valve. When I make my cuts, what I want to be doing is just moving across the stone like so, and this one it's okay to bring it on and off. I'm going to bring my lubricant in on this side so I can lubricate that back of the valve as I cut. So I'm just going to start off to the side right here. And then I'm just going to give it a thousandths at a time. So that took about 0.02 off the back of the valve. And we just want to look at the valve and see it's a nice clean and refreshed cut. After I've cut my valves, I want to further go ahead and do some more inspections. First thing I'm going to do is actually pick up the valve. I'm going to bring in as much light as I can, and I'm going to make sure that there's no defects in the valve surface or the seating surface where it's going to seat against the valve seat. I've cleaned these valves down from the valve grinder. Sometimes it can leave a little bit of debris that can mask a problem. The next thing that we need to look at is the margin. And the margin is the portion between the valve seat and the edge of the valve here. The thicker the margin, the more heat dissipation the valve has. So the dimension that I'm getting on this one when I measure it, and this one looks like the valve's only being cut once, is about 1.87 millimeters. When I measure a new valve, it measures approximately 2 millimeters. So this one, between wear and machining, has lost 0.13 of a millimeter. When I inspect this valve, first off, we can physically see the difference where the margin on this valve is considerably smaller. And then when I go ahead and measure this one is measuring at 1.27 millimeters. So it's lost approximately 40% of its width. So I would not use this valve in service, even though we've gone through, we've measured it, it measures up to spec, we've resurfaced it, but after resurfacing it's no longer serviceable. So I'm going to move it over to our dead pile. I'm going to do the same with our intake valves. We're also going to look at the margins. The margins on an intake valve are considerably less than that of an exhaust valve. That's because the intake valve is constantly being cooled by incoming air and fuel, whereas the exhaust valve is constantly being heated by the outgoing combustion gases. And I'm just going to do the same thing where I'm just going to go ahead and measure these margins. And we've got 1.25 on that one, or 1.22. And 1.32 on that one. The last check for the valves themselves is to insert the valve into a cylinder head and measure the installed height. So I have a cylinder head here, and I'm just going to start with my intake, and I just want to push it all the way in. We haven't done any more work to the cylinder heads other than cleaning them up. And our installed height is the dimension as measured from the back of the valve, with the valve all the way up against the seat, all the way down to this machined pocket right here. Now the specification from Porsche is 47.5 millimeters plus or minus 0.6 of a millimeter. So I'm just using my vernier calipers. And on this one we've got 48.1 millimeters, and that is right on the usable length. So discard would be at 48.1, and we have not cut the valve seat yet. Now this measurement is going to be also affected by how much we have to machine the valve seat to correct the angles there. The next check is to take a new valve and install it into the head and retake that measurement, and if it comes up between that 47.5 plus or minus 0.6, then we know that the seat is still going to be usable, but this valve is not. I'm going to do the same with the exhaust valve for that same cylinder head. The installed valve heights are the same, both intakes and exhausts. So I've just got it, I'm holding some pressure on the back. You want to make sure that your vernier calipers are nice and straight and not angled in any way. and on this one we have 46.95, so a little better than the intake side using the other valve, but still pretty close to the maximum wear limit. We would go ahead on this and recut the seat, and then I would remeasure it and see if it's still within tolerance, and most likely still end up replacing the valve. When it comes to valves in air-cooled engines, I have rarely reused them. The valves tend to take a beating. They see a lot more heat than a water-cooled engine, and they tend to wear a lot more. We've gone through and processed these valves as if we are reusing them all the way through, and probably have about 3 hours of labor in these valves right now. After all the cleaning and machining, none of these valves are serviceable, and we will be replacing all valves.